My name is Debbie Penko, and today I'll be going through Advanced Modeling in RISA. Today's webinar is really going to be a fun webinar. I really enjoy this one because we get to show off a lot of the different tools and features graphically, how to manipulate a model. So not a lot of slides here. What I really just want to do is jump into modeling for you. The major thing today is we'll be focusing on the specific modeling, less on the analysis, or we can talk a little bit about other things when we do the model, but we probably won't take any of these models to results. We have upcoming webinars for loading and P-delta on the schedule, and those will get a lot more into the actual analysis and results. But today will be really much more on the input side, so we get to be a little bit more creative. So the first one I'm going to jump into here is going to be actually looking like this, this tower here. And let me just get into RISA 3D. So I built this already, and what we'll do is we'll build this from scratch as well. But I wanted to show you kind of what this will look like in the end, so you'll have a little bit of an idea. So this is going to be a maybe what we would think for an airport tower, but it could be actually for anything. And what we're going to really learn about is a lot of how what goes into creating this type of a model. Plates and members combined, all sorts of different conditions happening here, different geometry. So I'm going to start by creating a new model. So we'll get rid of that one, and we'll start from blank slate here. I'm just going to say close. And the first thing I like to do in that model is to start with the towers. The high-level generation tools are good tools, and what I like to tell folks in here, these are good starting points. So this shouldn't be an end-all, do-all of the whole model, but what it does is gets us really fast into a quick model, and then we can make modifications from there. So even though we're not doing a tank in this model, this really fit that rectangular tank shape for those towers. So I'm going to click on that, and I'm going to create a tank, what we also are calling a tower. So here we're going to start with the 0, 0, 0 origin. Our tower is going to be 140 feet tall. The width we'll say is going to be 9 feet, and then the length is going to be 9 feet. So the width is determined there, and the length is just that direction and the backwards there. You can put members in, stiffeners, all sorts of information for that. I'm going to actually keep this as a solid concrete tank, or what we were going to call a tower, excuse me, and we'll give that plate material 4,000 normal weight. The plate thickness is going to be 10 inches. Again, you could also put stiffeners in here, but I'm going to leave those blank. And we're not going to put any hydrostatic. This is going to be just, we're not putting our loading on there. So I'm going to say OK. And in the back, you'll see there's a model in our main screen, but also it highlights the model that got created. So I can either just close that out and zoom back out here, and I can see that it created a 140-foot tower for us. So I'm going to take this drawing grid that's kind of hovering in the back and get rid of that just so it doesn't confuse us. And what we'll want to do is really start by modifying this tower. So the one thing we're going to do duplications of this tower, and the reason why I want to quickly modify it so that we don't have to draw that on all 4 edges of the tower. So what we'll do is we're going to create columns that come outside of this tower. So I'm going to change this from rendering to wireframe. And I'm going to pick out each corner of my nodes there. So if I just select the nodes themselves, I actually am unselecting them. And the way I can select only those nodes is using this reverse selection, and it picks out just those corner nodes. And now I'm going to copy those nodes up. So if I select copy, I can copy them up by, let's say, 4 feet. So my total tower height there is 144 feet high. Now, I want to draw in columns. Before I start drawing, the best way to do it in a complex model like this is to create section sets. And what section sets do, it allows you to group different similar items together. So I'm going to call all of these columns similarly, columns labeled. You can be more creative with your label names, but I'm going to leave it at W8 by 10. Later on, you can modify those things. And the type I'm going to call it is column, and I'm changing this to A992 because this might be more common. While I'm in here, I'm going to create a bunch of different section sets. So they're ready and available when we start drawing. So I'm going to say a beam, for example. We'll make sure that that's a column type beam. I'm going to leave the shape for now just general. That way we come back, we'll make all those modifications at the same time. Tower, let's call this a tower brace. and we'll also create a cross brace, and we'll create a tower ring, a tower cross brace, and you can tell I'm not very creative with these names, but tower diagonal and maybe a building tie. Okay. So with all of this different types of members, what you can do since you group them all together, you can really just disregard the shape for now because it's just a placeholder. Later on, when you start to actually care about what you want, you can then go back and place the shape in there for you. And it will change everything in the model that you've assigned that way. So I'm going to go ahead and just say start drawing those columns. So I'm going to draw new members and go over to Hot Rolled, Assign Section Sets, Columns. And I'm going to say apply, and I'm just going to connect those nodes that we copied up. So I now have a top column there. The other piece I'll do is just maybe connect this entire rim here, so this will be the beams that we're going to lay out. So I'll say beams, and I'm going to connect these as well. Just help us get started. So with my top of my tower completely in place, what I'm going to do now is really start copying this tower. We had 4 legs or 4 towers above this. So what we want to do is we want to use our copy tools to help get us there. The copy tool has changed a bit over the last couple of years here. So you'll see that you can either copy point to point. What I'm going to do is copy, first of all, just clear all my entries in here. It remembers what you did last. So the last time you were in here, it actually remembers what was in here. So I'm going to do a copy. I'm going to copy this by 30 feet in the X direction. So the whole tower is going to get copied over by 30 feet. Now, what I want to do is also copy this diagonally in a couple different directions. So what I'll do is unselect that copied tower, and I'm going to copy again. Now, when I'm copying in here again, I'm going to push the clear button, so it just clears that. And I'm going to type in a 15 in the X direction, so that's going to go off by 15. In the Z direction as well, it's going to go by 15. So that's going to be giving us 45 degrees, just placing another one. Now, the important piece here is to say use increments simultaneously to perform a skewed copy. That's a long way to say diagonal. So we'll just say check that, and that will copy diagonally. So I'm going to say apply, and in the background, I'll see that I got it copied diagonally. Oops, I think I actually copied it the wrong. Well, let's see. I think actually I'm good. Let's take a look. And then I'm going to go ahead and copy the original. Let's put our reference in here. And I'm going to copy this one more time. So I'm going to unselect, and I'm just going to copy the, I think I actually copied that, that should have been in the Z direction instead of the X originally. So I'm going to try one more time here. So I'm going to go ahead and undo that and redo this. Undo and redo becomes a very helpful tool. So if we copy it right there, there we go. So what we're going to do is actually unselect. I think we unselected the wrong one. So we'll select this one instead, and we'll do that copy tool one more time. Oops. And 15 and 15 use diagonal. There we go. And that's exactly where we want it. If we're looking down, we're actually going to see that pattern a little bit better there. And so now I'm going to unselect that. And we're going to select the original one more time. Sometimes looking down on the model makes it a little easier. So use your tools definitely to orient your model in an easy way to view it. And then we'll copy this one more time. Oops, I'm copying right there. Let's copy one more time. And in this copy, again, we're going to go diagonally. We're going to use it in the X direction here, positive X direction, but we're going to use it in negative Z direction. So we actually copy it off to the left side now. And I say copy and apply. And I can see there, now I have all 4 legs of my towers in place. So again, if you make mistakes, always the undo button. It's never going to have too much problems. It's just undo it and redo it again. So now I'm going to select everything back on my model. And what I'm going to start doing is creating a ring around the top. Now to create that ring, I'm going to kind of want to know where the center of my model is. I can start figuring out that mathematically, but it's just as easy to find it using our model. So what I'm going to do is just sort of draw in some pieces to find the middle of our model. So I'm just going to, let's see, unselect everything and just select the very bottom nodes. Let's see, if we look down on this model here, we can see we're looking just on the base of this model. First thing we can do actually is that we had plates at the very base because this was thinking it was a tank. So what we might want to do now is really just delete these plates that are selected. If we look at this again in XY view, we can see it's just the base of that tower that is now selected. So what we'll do is we'll just delete all the plates that are there. This is, again, just modifying the high-level generation tool. Now, once I deleted those, I also found myself, I have all these extra nodes. So let's delete unattached joints while we're doing that. Say apply, and it will delete anything that was unattached. So now we are just back to the very base of the model with no plates. And I wanted to, my original thing here was to find the center of this model. So what I can do is I'm going to just draw in some general shapes. So I'm using general so that I'll remember that they are not actually part of my model. And I'm just going to draw here on these edges, drawing across. So I have a center line in between each there, and I can now find the center point of this line and just use that center line. If you look at the bottom right corner of my screen, it says half point. And that tells me that's the half point of that beam there. And I can cross all the way across to the half point of that one, and I can draw all the way across to there, just making sure. Now, if you had an odd geometry, mine's very symmetrical, this would help find where a center point might be. So you could find that a little bit easier. Now, what I'm going to do is do a model merge, just quick model merge on this, and it will add a joint right in the middle there. So now when I hover over that joint at the bottom right corner, I see it says 19.5, 0, 4.5. That's the center point of this model. So that will help me, and we're going to remember that. I have that jotted down so that I remember that point the whole time that we're looking at this model. When I draw a ring around the top of these, what I'm going to do is actually do a radius. So what I need to do also, since I want this node, it makes it very helpful, is I'm going to use my F5 button. It's going to create a distance tool, and I can measure that. And I can actually find now the radius. That's the longest point here around this entire square, a rectangular shape. If I look at this F5 and I click on that, it's going to give me a distance here. So the distance is 20.0125. That's my radius. Okay, so if I look around here, that's going to be the radius no matter where I click on here. The farthest point is going to be that 20.025. So F5, if you're not familiar with that, that's one of my favorite tools, and a lot of folks don't know that one. It turns into a distance tool. It helps you measure things. Okay, so what I'm going to do now is I'm going to look back on my model. I'm going to select everything again. I'm going to look at an isometric view, and I'm going to zoom out a little bit. I have that center point at the base, and what we're going to do is add that ring I mentioned. I'm going to just highlight that a little so we can see what we're looking at here. So the ring, I'm going to use the high-level generation tools. I'm going to use my circular arc tool to create a circle. So you could do a parabolic if that wasn't exactly what you had there, but I'm going to do a circular arc using a perfect circle of 360 degrees. Now it's asking me where to put this circle or this ring. And what I want to do is I'm going to put it, okay, in my origin, around the origin is exactly what we just found, 19.5. The top of the location is 144 feet, we said originally that's the height of the tower, and then 4.5, that's the z-coordinate. So when we found that center point, that's these numbers. 0 is my start angle, and it's going to sweep the full 360 degrees. It's going to go a rotation angle of y around the y-axis, and we're going to tell it to use an arc radius there. We're going to say that's that number we found, that radius, which is 20.0125. So I just happened to jot it down so it's easy for us to find. And I'll basically go around that whole arc 180 times. So each increment will go 180. This number is just up to you, how tightly you want to space things. So what we'll do is we'll call this the tower ring for the section set. Again, a good reason to use section sets is you have them now available on these drop downs for these advanced tools. So I'm going to say OK. And then it selects it for me. It opens this big new window. Now, I am going to actually use this window because I don't really want to see what's happening below there. I'm really focused on what's happening up on this upper level. And in particular, what I'm looking at, if we zoom in, first of all, I'm going to get it out of rendered so we see. Now, one of the problems here I'll notice is that I have actually, looking at this, I'm looking, that's the column right there, and it's hitting in the midspan of my actual ring. I'd like it to hit on a joint, so it's just a little bit more clean. It's actually, since we have physical members, this is okay. But maybe later on, if we were thinking plates or anything else, it would just be a nice, smoother, if we actually move this over. We can do some measurements, again, using our F5 tool to find what actually the radius is there, so how much increments we need to actually rotate this ring. So what I'm going to do is I'm going to click on this toolbar. If you ever lose your toolbar there's a pencil right there. It pops right back. As a beginning RISA user, I used to lose it a little bit, so I just always like to point that out. So what we're going to do is we're actually going to rotate the entire model, the ring, just the ring, whatever is selected, and I'm going to unselect that column just so we don't rotate that. And we're going to actually click that rotate button, and we're going to rotate this about the y-axis, and I'm going to rotate it 77 degrees. Again, we're going to remember that those coordinates for the polar origin, we just typed them in earlier. It was 19.5, and the y is 144, and the z is 4.5. So it's actually going to turn it right around that polar origin. So a good reason to know that origin again. So I'm going to rotate it, and I now see that all of my joints line up nicely. Okay, so that's actually a nice thing. What we'll also have to do later on, and I'm just going to remember this later on, but we'll want to do a model merge because now we have actually two joints on top of each other right there, which is going to cause us a problem if we don't model merge. But that's okay for now. So we've now rotated. We're looking at this upper location. What we now want to do, let's take a look at the entire top of this area. So what I'm going to do is select the entire area up there. And if I look back in isometric view, I see what's happening on this level here. It's a little hard to see. So does everybody have that problem sometimes in a three-dimensional model, you start seeing all what's happening behind it. So what I like to do is I like to click on this lock button. So I'm going to just lock out the rest. Now what that does, it turns off the rest of the model in the view. It doesn't actually go away. If I unlock it, there it is again. But it really helps you in 3 dimensions. Now I can sort of rotate around. Now, one of the problems you have sometimes, maybe you want more in there. I can maybe bring back those columns, and if that helps me, just select some of that, more of this area. I can say, let's select the columns back and then lock out that. So I see a little bit more. Maybe it's helpful to see a little bit more information. So now I can see all of that, and I don't get confused with the background. So what I'll do now is start drawing some of the ring information inside. So I'm going to draw new members, and I'm going to pick out some, that was the tower ring. We're going to call these tower braces. Actually, sorry, I'm going to call these tower cross braces. And I'm going to start drawing things around here. So I'm going to draw around here as I go. And what we'll see here, I've got now, I can maybe even tie these back because this is a big span. So maybe we'll tie these back. And I'm not quite paying attention to pinned end releases. What you can do, since we are using section sets, it's really easy to isolate the type of member you're using later on and change it. So that's another really good reason to use a section set. Whoops, it's a little crooked, but let's see. I'll pick out this location here so we're a little straight. And I'm going to keep rotating. Now, if you're asking yourself, how am I rotating, I'm using my Shift key and my middle mouse. So I'm holding my middle mouse and I'm rotating things around. So you should be able to do that. Sometimes when I'm stuck on a projector, I have issues, but in most computers, you can just hold your Shift and your middle mouse and everything will rotate around. So you've got that all in place. So now once I've got all of that, all my bracing in place, I do want to do a center ring. And one of the tools I have to do the center ring is I have a offset tool. This is a new one that came in a last version, I'm pretty sure here. It says it will make parallel copies, increments, selected direction. So it's just like using an offset tool in AutoCAD. So what we're going to do in here is I'm going to actually display my local axis. That'll help us understand. So what we want to do is we offset based on, let's look at this straight on here. Sorry, let's zoom in a little. If we tried to offset this in the global axis, then it wouldn't really work because we want to actually do a center ring just like the ring on the outside. So what we'd have to do is use our local axis, and we can see that we have I've been a little bit haphazardly drawing this local axis. Some of my local Z direction is pointed in and some is pointed out, but we'll handle that right now while we do that. So what we'll do is we're going to use this offset tool, and what it does is it copies that increment in each direction based on the direction you pick. So what we'll say is we're going to say 5 feet, and it's going to offset that in 5 feet, and we're going to say copy it in the local Z direction. I'm going to keep this dialog open as I go, and I'm going to say apply. Now, I'm going to go in the positive Z direction, so I'm going to go positively this way. So wherever the Z's are pointed in, I'll do an offset in that direction. I'm going to offset this direction here. I'm going to offset this one, and I'm going to offset that one. Okay, so those are going to be all offset. Now, the other ones are pointing inward, so all we have to do is just do a negative sign, and I then offset those in those directions as well. So I say apply, everything that's pointed inward. We're going to actually copy those as well. And last one. Okay, now I'm going to push close. It's a little distracting to see all those local accesses, so I'm going to turn the local access label off. If you don't have these buttons, by the way, at the top, these are really great handy buttons, so you should be able to quickly get your local access. We can color code. We can look at the INJNs, things like this. These tools are really helpful. If you don't have them, you can get them from your Tools Customized toolbar. Okay, just a side note, this is where they came in from. What I always do is just push the reset button, and they'll all pop in the ones that I'm using. But if you want to use your own, you can actually use this customized toolbar and select ones that you do. So if you're using plates a lot, you might want to use a lot of these quick buttons here. And what this does is it allows you to quickly gain access to the stuff you have in plot options. So I'm going to close that. Now this is kind of a mess, right? So I couldn't actually work with this the way it looks right now. So what I'll do is I'm going to just select just what's inside of this area here. I'm going to actually use my line tool and just select some of this stuff. And I want to model merge this so it actually creates joints along there and I can get rid of the extra. But what I do want to do also is I want to be able to just not have to redraw this around. So I'm going to actually make these non-physical members so they split the members up. Okay, so if you actually say non-physical for whatever was selected on my entry here and say apply, these are now, they have the physical checkbox turned off. So that means that when we do a model merge, perform a model merge right here, it's going to actually merge that area right there, and it's going to create joints, but not only create those joints, it's going to break the members up. If they were physical members, they would not be broken into pieces. They would just have a joint added. So what I'll do now is I'm going to just select everything back on there, and I'm going to delete the edges. So I'm going to go ahead and say delete individually and walk around this area and delete that. So this helps you that model merge and non-physical members is just a quicker tool right here in order to just get rid of these extra pieces. So now I have a center ring very similarly to that outer ring. So what I'd like to do now is just draw some members to connect that. I'm going to say draw members, and I'm going to go ahead and draw diagonals here to try to connect that. Actually, I'm going to still use my cross brace, and I'm going to connect this to the outer ring. Okay, so you've got an inner ring, you've got an outer ring, and now that's just still two-dimensional on this level. We haven't moved up. So if we look at this in XY view, I'm looking at this, I'm just still seeing this at the 144-foot level. So what I'm going to want to do is select that and copy it upward. So I'm going to actually copy this inner circle here, not the full inner circle, but this one that's right in the middle, and we're going to copy that upward. So by using the copy tool, it remembers what we just did, so we're going to want to push clear, and let's copy this up. Okay, and we'll copy this up, I think here, let's do it by 5 feet. So let's say 5 feet up, and I'm going to interconnect the bays. By interconnecting the bays, I can tell the program to actually connect this copy. They apply, and as I look at it again in isometric view, I'm going to select all, I can see that it actually copies it connects that copy from the upper level to the lower level. Now, it doesn't really know what I want to put there. So it just goes ahead, let's see, and let's display the shape. It just puts an RE1 by 1. In RISA, that's kind of what we call a placeholder. RE1 by 1 means a rectangular 1 by 1 shape. It really has no idea what that means. What is an RE1 by 1? So what I'll do is I can unselect everything, and I could go ahead and I'm going to select by criteria. So if you're not familiar with this button here, this will allow me just to select certain things in the model. So I'm going to go ahead and select members, and I'm going to find all my RE1 by 1s. just an easy way to find things. So I'm going to say section set, shape, shape, RE1 by 1, select those members, and then let's modify that. So we can go ahead and come back in here, and we'll change, instead of using RE1 by 1, we'll call those columns, because those are actually little baby columns there. So we'll say use columns, make sure to uncheck the physical members, and do everything that's selected there. So now these become columns. They're using our 8 by 10s, but if we look at our section set, they now say columns. We can also color code those so that they look like the color that they are. Oops, the section set there. So those are the columns. Okay, so now what I have everything on this level. I'm going to just select it again, and I'm going to go ahead and I'm going to do just what I had, sort of a bird's nest on the top of that. And so what I want to do is unselect the top, and I'm going to just copy that all the way up. So if we look at this here, we're going to actually copy this whole area up. And I'm just going to stop our color coding so it's just easier to see, and our labeling. Okay, so I'm going to copy this again. I'm going to go up by 20 feet this time, and I'm going to say copy it up by 20 feet, and I'm going to unselect the lower portion of that. And then, since it's really not just a tower that was stacked, it was like we said, a bird's nest that actually comes out. What I'm going to do is going to scale that. So you can kind of figure out what your scale would be. I just did a simple kind of, let's see, 1.5 in the X direction and 1.5 in the Z direction. What you do need to do, again, is make sure you remember that origin point. We said our origin is 19.5. and 144 feet. We can actually keep our 0, but I'll say 144. But the big key there is our 4.5 and 19.5. That's our origin, and I can say apply, and it will scale that up. Okay, so now I can actually go ahead and draw diagonals to connect these. We could also connect those using the connect with the copy button again. But this is sort of a nice way to go too. So I'm going to draw point to point. We'll choose our diagonals this time, tower diagonals, and I'm going to draw this up there. So we can just scroll around and look here. Now, one of the things we've got in here, we have a lot of columns and bracing. What we want to probably do is brace this upper area. So as I roll around this model here, we're going to probably need to brace this upper area. So it's not going to just freestand all the way up there. We're going to probably have to put some rings connecting that. So what you can do to find points to connect to, when you draw members in RISA, you have 3 third points. Let's say we're going to be doing a cross brace here. You have selection points, like you have here a third point, you have a half point, you'll have quarter points and third points. It's easy to snap to, but if that's not exactly where you want to snap to, then there's other ways to do that. So what I'm going to show you here too is that you can, let me unselect that lower portion just so we get that out of the way. So I'm going to unselect this bottom half here, and I'm going to lock that out so we just are looking at the upper portion. Okay, so now what we can see is if we use our F5 button, we can measure how tall this is. So it's approximately 20 feet. Okay, it's measured from the bottom top. I drew it from bottom to top. I could verify that by looking at the I to J ends. So we're looking at a 0 point here and approximately 20 feet up here. So another way to draw members in there is to draw them based on, I always draw point to point, but you can draw member to member there. So I can draw some bracing in here, and I can put it in at maybe 15 feet. So it doesn't have to be on a specific quarter point or third point or half point. I can actually put a specific point on that member. Again, this is very easy because we're looking at members that are all the same size. So if I click on that 15, you see when I clicked on it, it created a joint right at 15. Okay, and I clicked to the wrong point, but let's see here, there. And I'm going to click on this member right there. So you see how it hit 15 feet on that location, on that member. Now, that's not exactly 15 feet because we're looking at a diagonal. So it's 15 feet around the rake, which is nice. It actually calculated that exactly along the rake. So let's click on here, and I'm just going to go around there. So there's some tools. Those offset tools are really great ways to calculate exactly a member-to-member offset. You can also do a joint to a member. Whoops. And we'll scroll around. So that's another, these tools down here. So yeah, I did member, first offset is 15 feet, second offset is 15 feet. That's how I found those members. But member to point as well, you can get a point actually and just measure that offset that way, or you could do point to member and find that offset in that direction. So from a joint, or we call it a point, to the member, you could have said 15 feet. And that would have measured from one joint to that. So you've got that level there too. I'm going to also just lastly just draw in those some, we call those building ties, and we'll do point to point. And we'll just look down on this model here, and I'm just going to draw straight across and tie this off. So these are a little bit, these might be maybe your heavier beams on the top there, maybe to carry some elevator loads or a lot of things that are coming up this way. So I've got the whole tower, or what we call maybe our building portion on the top of the structure all in place. What I'd like to show you too is that you can go ahead now, I'm going to open up the section sets, maybe that building tie, that's a much bigger member. An 8x10 is a small member. Maybe we really had something large up here, so we can pick that member right out there, and automatically those members adjust. So using section sets doesn't mean you have to plan it too far ahead, just gives you the ability to really use like members together, and then you can adjust them after the fact. I can even break members out of section sets if I need to. If I double click on this member and I look at it and it's a beam, but maybe then I just say I really want to do it specific to a different shape. I need to go ahead and call that a tube for some reason. Maybe this is a specific type of member and it's not a section set anymore. Okay, so as soon as I do that, it's out of the section sets and it's its own member. So it's not rigid that you have to use them, but if you do, then you can break them out too. Okay, so now once we've got our whole tower adjusted, we still really didn't think about much on the concrete lower level. And what you can do is you really work with that lower level and start to adjust that. Now, again, like I said, 3 dimensions is hard to think about all the stuff going on at top and then work on the bottom, especially if we want to start looking at it downward, because those beams are going to get in the way. So what I like to do is I like to do selection states. So what we'll do maybe here is I'm going to let's look at this model sort of if we look on it in the YZ view. What we'll do is we'll unselect the entire model, and I'm just going to select that lower portion. So if I just select the lower portion, I'm going to lock out that top portion, and then I'm going to go to View, and I'm going to say here, I'm going to do recall this. You have a couple different things. You have selection states, and I can say selection state there. I'm going to only have this retrieve the selection, whatever's been selected, and I can say save, and this can be tower. Okay, so that's going to save the selection state there. So when we recall it, I'm going to actually show you how that works. So if I unselect everything and bring it all back and we look at it again here in isometric view, this is the whole tower. I want to just look at the bottom portion. I can go back and pick up that tower retrieve and just get that lower portion. You also have views, and views will help you from the perspective. Okay, so we're looking at a certain angle. But selection states are usually the easiest for when we're looking at this way. So now with our selection state, we have what I want to try to do, maybe we can delete portions of this model out of the model. So we could do things like select, so these towers probably aren't just boxes, okay? We need access into there, okay? These are just 10-inch wall, thick concrete walls. They're not going to be empty, dead space typically. So what we can do is maybe delete just a portion of those out. You still see my center beams, and I'll just leave those for just a little longer. Those can probably be taken out eventually here, but we'll just sort of remove some of this area in here. And I'm just selecting, if I select downward like this, what I'm doing is I'm actually selecting everything in that entire tower. So when we look at it in this view, we're looking at everything downward. And I can delete a whole section of that. I'm going to go ahead and say delete selected plates, and then I'll say apply, and all those plates will go away. And then I can delete unattached joints, and I will be able to delete all those joints that were hanging out in the middle of that area. And now we have an opening inside of there, okay, wherever it wasn't connected there, we have some openings. I've got a couple joints down at the bottom that are still connected. We might want to clean those up. So I'll go ahead and just delete those. But then you can just basically walk around. Maybe we'd actually delete some of this bottom portion out here. So you can walk around and put some bracing in and all sorts of pieces in here. So I'm going to go ahead and delete a lot of this stuff in the bottom. And we'll just, let's see here. We'll close off all this area. So we'll get rid of all this. Now I'm going to be rendering and unrender this a little bit. Okay. So now, last piece here I want to do is I really am going to have to support these towers. And we're probably not going to freestand. We're going to have to kind of connect them so that they work as an actual unit rather than just singly, and really brace them. So what we'll do is let's look at this tower by itself. Again, every time I'm pushing selection, since I'm locked out, I'm not getting the top portion, which is nice. Okay, so what I'm going to do is I'm going to unselect the tower. I'm going to go ahead and unselect everything and just select a portion of it. It's kind of hard to see, actually, what you're looking at here. So what I like to do is sort of pick out one maybe representative joint, and that'll help us. So maybe at 14 feet there, I see one. I'm going to select all of that area, and I'm going to lock everything else and then lock it back there. Now I just see that area there, and I can now connect these. So what I can do is draw in some members. We can go ahead and use this. Let's see here. We're going to use now tower braces, and I can draw some of these pieces together so that they connect. So let's see, connect here. And now it's kind of a good point to mention to you at, let's see, I want to do, I'll do some of these outer ones. And now these points are going to actually connect. So one of the important pieces of what you're seeing here is I'm drawing members on top of each other. And now what you want to ask yourself when you're doing this is, do you want to model merge? And if you don't model merge, that means that the loads between that happen, and anything that happens along this beam and the beam that crosses it will not get connected. So if you just see a member across there that does not have a joint at it, and you don't model merge this area, then what will happen is these will just act independently. If we do model merge it, it will get a joint there, and then those will actually interact. So that's a question you'll have to answer on your construction. Are you going to connect those points? Are you not? If you wanted, folks a lot of times ask, hey, how do I make two beams go through each other in the same area, close to each other, but offset so they don't? This is exactly how you might do that. If these are in the same vicinity, but you are not going to connect them by construction, then you would just draw them right across each other, and they're not going to share actually any load between them. So that's something you'd want to decide. And one thing to be very careful of is that you don't actually just draw them, draw all of those, just draw them and model merge quickly and not know that it had consequences. So model merging is a good thing most times, but sometimes it can get you into some trouble that you didn't realize, especially with crossing elements. So now once I've got this, I unselected all my joints, and what I want to do is I want to copy this upward. So I'm just going to unselect that so we see the copy a little bit better. And I'm going to unselect that, and I now see that just this area is going to be copied. So I'm going to copy that upward. I'm going to do it in increments. One of the nice things on this copy is that we can do it several times. So I can select that joint, that area, and it's going to be copied up 8 times at an increment. We said the joint was at 14.7368. And I'm going to copy that all the way up. So it's going to land all the way up at each point. Now it's very important that you get that number right. I checked my number before we started, but it's very good that if you don't hit this at a joint, then you're going to have some problems, especially because we're looking at plate modeling. So you need to have that hit at a proper joint. Otherwise it would be landing in the middle of a plate, and that wouldn't accomplish what we wanted. Okay, so basically, this is sort of where I'm going to stop this model, but I want to show you it in its entirety. If we look at the model again here, it looks like we have some bracing. We're looking at an isometric view. We've got this little tower on top. We've got the plates, and those there you can see as I scroll around. We have access into those plates, so it's not what you'd think of as a tank, but that's what we use to start this model, so it's a really good tool there. Okay, so let's see here. That's kind of our model there. And what the next model I want to do is very similar here to, let's see, I'm going to just show you a quick shot of that. So this model is a dome. And I like to show domes because it also does show a nice way to model things. I'm going to show you a different way to do a dome and than I normally would, because we have a different feature here that we can actually show off a little bit. But what you can see in this dome is got two two different types of radiuses on this, and so it's a little more complex than your normal dome, but let's take a look. So I'm going to start a new model. So I'm going to go to File, New, and we won't save that. I have that already saved, so we'll go back to that. And what I'm going to start out is I'm going to actually do some section sets just to get started in this model. So I'm going to have some columns, I'm going to have some arcs, I'm going to have an arc brace, and I'm going to have a ring, and maybe a column brace. That should get us started. Again, you're going to come back and address these things. I just maybe call that column and beam. You can come and address all of the different shapes later. But what we have here is I am looking at trying to do, sometimes what I usually would do is use that circular arc. But I already used that in this webinar, so I want to try a different way. And this one is, we're going to work outside the box a little bit. I'm showing you a feature that's brand new, actually hasn't been released yet, so I just want to show you how, and it'll be coming soon in the next version. So you always have a drawing grid, which is this gray grid in the background, and you can always see that's kind of hanging out. It's 30 at 1, and you can adjust this drawing grid, and you can change the planes that it's located in. So this has always been available here, and you probably didn't think about it too much unless you had to adjust it. But what's new is this import to DXF. So from a DXF, excuse me. So we can always import a model directly from a DXF. In my last model, I'm going to show you just a quick import, very easy. But in here, what I want to show you is you can actually import a drawing grid, so you can have somewhere to click to. And the drawing grid, you can choose different information. So we can choose where to have the origin, where to have the drawing grid plane. The actual drawing grid that we're going to do is going to actually be what I call here from AutoCAD. You can see my screen. My screen is very blown up from my display. Sorry about that. But what you can see in here is this is I drew this complex type of radius, and I wanted this to go right into RISA 3D, and I want to be able to draw it and create a model in here. So if for some reason you've gotten yourself in a much more complex, this is not as complex as it gets, and you want to be able to draw to them and click on this once you get into RISA 3D, you can use this as a drawing grid. So let's see, I will choose the angle increments for arcs. Mine actually has an arc in it, so I'm telling it to bring in every 5 degrees of that arc. And I'm going to just click on that Multidome file here. And what it does is it lets me pick all the layers, or it tells me if I want to pick specific layers. I can actually color code things too. So if I want to show different colors on different layers, I can do that as well. So I'm going to say OK. And now what I see is I've got a drawing grid in the background. Now this is not a model. This is just a drawing grid. Okay, so just like we had a drawing grid that was an actual grid, this is just where we can click on. And so what we are looking at here, I'm going to just draw some of my members on top of this grid. So it's a column. I'm going to go ahead and draw in that column. I'm going to be able to click to it. You can see I can click to the edges of that. And then I'm going to draw on that the arc. Okay, so I'm going to say the arc there. I'm going to be able to draw on this arc. Now where I can click to is 5 degrees, every 5 degrees. That's because that's what I told the program to import that arc in as 5 degrees. So you can go lower, you can go higher. That's adjustable for whatever you selected there. So I'm going every 5 degrees, up, up, up there. And I'm going to hit the middle because what I want to do is a dome. So this is going to be a 3-dimensional for me, not just a 2-dimensional. So and the reason why this might also be a very good reason to do this is it might be harder for you to draw in 3 dimensions with plate elements in an AutoCAD. So you just want to get started in here, and this is kind of a nice way to get started that way using a drawing grid. So I am actually going to turn off that drawing grid, and it goes away. And now I can do is I can copy rotate this around. So we're going to now get started on this dome part. So let's see, I'm going to click on that so you can see a little bit better. And what we're going to do is we're going to copy rotate. And in here we're going to copy rotate. We're going to tell the program to copy rotate around the y-axis. And we're going to do a 22.5 degree increment there. And we're only going to go one time, okay? And I'm going to click to the origin point, and I'm going to tell the program here the origin is right in the top of that dome there. So I only did one increment. Reason why I'm only doing one increment, I'm going to place a lot of the work in this one increment, and then we're going to copy rotate the whole thing around. So I've got all of my arc in place. I've got all of my column is in place, but now let's connect the two together. So let's go ahead and draw new members, and I'm going to place in a ring. So I'm going to draw the ring in there, and I'm going to just copy this here. This would be the ring that goes around the entire thing, and maybe we'll just put one in at the half point there too. We also want to brace that the arc area there. So let's see. If we look at this, I'm not going to actually brace it every single time. That's a lot to put in, and you're probably not going to build that many. Maybe you will. It depends on maybe you have to put it in later, but let's just put it in every maybe third there. So we'll put in kind of at third points here, and I'll put this right here, and then we'll keep going up the structure, and I'll see here that I've got. Let's just do that there. So we've got, this is our bracing in that arc area. What we also can do is we can now start to draw in some of those plate elements. Now this is important to talk about the plates. When we're drawing these plates, I'll just start with a 1-inch plate. And what I'm going to do is I'm going to draw in these plates. I don't want to draw a big massive plate like this. Why don't I want to do that? Does that make sense to everybody? It's actually, I'm changing slope. So if I started to do just a massive plate like this, you can see just from that red line. And this is kind of a good, see, it won't really work. This isn't connecting to that point. So it's just math, right? As you draw this line to this point, it misses the slope. So what you're really going to want to do is draw all the way around each point. So a good reason why did I do 5 degrees? 5 degrees felt pretty good, but yeah, it's a lot of times to click here. Not too many, but enough that I feel comfortable that I'm going to get a good sub mesh, and we'll see. I'm going to actually, I'm going to sub mesh more beyond this, but I'm just going to make sure that I got the slope I want. So sometimes people think they want to get real accurate and they want to break that into even less, which is fine. Just means you got to break your plates up less, and you have to do a little bit more legwork on drawing plates in. So we're going to see, I'm just going to go around. Whoops, I clicked the wrong point there. And I'm going to keep going and almost done with this. I'm clicking, sorry, a little bit messy today. So why would that have been bad if I overlap plates? Everybody know what plate modeling there. You want to draw joint to joint, corner to corner. You don't want to have overlapping joints. You don't want to have joints that land in the middle of a plate. We mentioned that earlier, but it's very important that you draw your plates accurately into each corner joint. Otherwise, they're not going to share loads well. Okay. So we can see I have one triangle at the tip there, and I have an extra silly joint hanging out in the middle there. I'm going to delete some of these where I got a little messy, and just so we don't get a messy model here. And now what we can do is I can now submesh this, okay? So I didn't have to draw all these teeny plates. What I can do is just say, draw my plates. I'm going to go to the quad mesh, and in that quad mesh, I'm going to say, apply a quad mesh to all plates 4x4. And that's as easy as that. They all get subdivided. Now, the one that does not get subdivided is up here because guess what? That's not a quad. So it needs to be broken into a triangle. So what we say is that's a tri-submesh. And so I can click on that, and I can apply that, and it breaks it into actually quads or rectangular shapes for me. From there, it's still not good. Now let's talk about that. So this big plate meshing to two small plates means that this is not a very nice mesh because what we said is we're not connecting to the corner nodes. We skipped the corner node there. So what we'll do is we'll just do a 2x2. Go ahead back to the quad mesh, and we'll just say 2x2. And we're going to apply individually and click on this one, click on that one, and I'm going to click on that one. Now I have a nice mesh that everything was working out, connecting. All corners are matched to other corners of plates. Okay, so I'm going to zoom out a little bit, and now I'm going to add some of my boundary conditions. I'm going to put some, let's say this is going to be maybe pinned, and we'll highlight the bottom there. We get a pinned boundary condition. One last piece maybe we'll end up, so we'll just draw in. Again, we're going to maybe use that draw member to member. This was a 20-foot column, so maybe we'll brace it at 18 feet. Okay, so we're going to column brace there, 18 feet up. And remember that was what we used last time, so we're telling the program member to member. It's going to go at 18 feet to 18 feet. And I'm going to click on this one, and it finds the 18-foot point, and click on that one, it finds the 18-foot point. Okay, so that's a nice way to draw that as well. So now once I've got all of that in place, I now need to copy this whole model all the way around. Okay, so the way we do that is going to do our copy rotate, and I click on the copy rotate. It remembers the last thing we did, so instead of doing a 22.5 degree increment there, one increment, we're actually going to swing 157.5. This is half of the circle, and we're going to go around them 7 times. Okay, that's basically what I did was I did 180, and I subtracted out 1 increment, and then we end up doing it. So that last one, that was 8 increments, and we said that was 1, and we did this, the last piece of this, and we're going to go 7 times around that. So, whoops, and it asks me where's my origin. Again, I click on my origin, and now it copies it out. Zoop. So the whole thing is copied out. So now, why did I do half? Because I want to put some bracing in, and it's easy for me to draw bracing once and then just mirror the whole thing versus drawing it twice. It's all about saving time, right? You want to try to quickly get into your model, in and out of your model. So we've got here, I'm going to just do some, again, column bracing, and I can maybe say pinned. Again, I didn't really pay attention too much to the end releases, but you'd want to do that, point to point, and I can draw in some of this bracing. So I'm going to say the bracing goes here like a big triangular bracing in that. And then I'm going to do is I'm going to tell the program that I would like to mirror this, so that I'm going to say instead of doing a copy rotate again, we're going to just mirror the whole thing around, and I'm going to tell the program that to go around the XY plane at 0 location. That's basically over here. If you see my right corner, it says 0, 0, 0, and so we're going to actually mirror all that. Say apply, and it's going to think for just a second while it copies all those plates all the way around. Now, lastly, this is, again, back to that conversation about model merging. What's happening is I did a lot of copies and a lot of rotates, and what did I do? I dumped that center column, that center node about, however many times I went around. That's how many times I dumped that node. Looks pretty good, actually, but it may be, there might be some kind of mixing and matching of these corners where I mirror things. So what I do recommend is doing a model merge. So what you'll want to do is go ahead and model merge. You can say all selected items and say apply, and it comes up with, actually, I did have 304 duplicated members. So it's probably when I had things copied on top of each other. Okay, so then I zoom out and then I look at my model a little bit here. What we can do, we can see this is kind of it shows us a little bit. Let's render it. So you can do all sorts of things from here. Now I really would start to go ahead, and this is where I haven't really even gotten into, but you would want to start working with the shapes. So if the columns are maybe not going to be 8 by 10s, especially on those bracing, the arcs and all that, that's probably going to be an angle. So you can work with those angles and start assigning what you want for all these angles to be. Maybe a single angle. We can pick out a single angle here, and we can see it automatically adjusts for us. And if we zoom in a little bit, you can see how that's going to be actually adjusted to an angle. These angles might not be rotated well. Now, that is something that if you ever need to rotate it, that isn't going to be section set based. That's going to be per member. So you'd want to go in here into the primary data and start to work with the rotation. If you know all of them are going to be rotated in 1 degree area, you can actually do is probably sort them. So and sort them by shape. So you can sort high to low and work with each member type, and if they need to all be rotated, it's just as easy as going ahead and going in there and selecting a block. So maybe all of those arc braces are going to be rotated, and you can select this entire brace arc here and rotate them by filling the block by 90 degrees. So now all of them are being adjusted. This is such an easy way, the section sets gives us such an easy way to group things together. We can do it in spreadsheets, but we could have also done that really easy graphically too, by selecting based on criteria. Okay, so you can manipulate it that way. So that was I wanted to show you specifically, I'm going to zoom out here, this model, because I really wanted to show you that new feature that's coming up here, that import DXF to our drawing grids. So this is a really cool feature. This is going to be in RISA Flora and RISA 3D. So that's a nice one, but I also, before we finish we're in the last couple of minutes, I do want to show you one more tool. This is you know, this has been around forever, but lots of folks always ask about this one, and it's not hard. I just want to indicate how to do it, is you don't have to have a DXF for a drawing grid. You can actually just do it for the entire model. So if for some reason you have a great model in 3 dimensions, this is working in AutoCAD is, in 3 dimensions is hard for me, but lots of folks send models that have 3 dimensions, so it's something if you can do, you've got one, you put all this work into it, and this is a 3-dimensional, looks like kind of a hangar or a spaceship, whatever you decide this looks like. You can import this whole model right in to RISA 3D. So the dome roof here, DXF, it's got to be saved out as a DXF, that's important. But when you go over to RISA 3D, you can just say File, Import, and then you can go from DXF File. So I can pick out that dome roof there. I have it in my CRISA folder there, and you can put it anywhere. You just have to navigate to it. Say Open, and then you tell the program where you want to orient things. That CAD axis there, I think that was, let's see, that was Z vertical, so that we tell the program Z is vertical. And I can tell the program to switch the layers to section sets. So I'll do that, so I have them all in section sets. I don't know that that model had too much to work with. Ooh, I do. So I already have section sets in place. So that model was actually had each layer laid out there for the different types. So now I have a model that's 3 dimensions. And this is a great way, again, to use all the tools we went through today. Maybe this is a starting point for you. And then then you need to maybe make the structure that goes below it. But you can use the tools we looked at, like copying and doing all the different options to get that so that it will actually just draw those members in very quickly for you. And then you can go ahead and start addressing what shapes you want in there as well. So just lots of different tools. Don't be scared to actually just try some of these tools. And the high-level generation tools, I love these tools for great starting points. Talked to folks yesterday who was looking to do an arch. An arch might be great for circular radius, and then you can sort of build off of that and draw around that area. So there's a lot of different things in the high-level generation tools, but they're not set in stone, so you can do whatever you want in there as well. So that is basically the end of my presentation. Thank you so much for your attention, and hopefully you took away a lot of good tools for taking into your RISA modeling.